What's up, everybody? Hutch here, and this is your Module 11 practice test. Let's go ahead and walk through this really carefully here. All right, Lesson 1 is all about vertical angles and complementary, supplementary, that kind of thing. So let's go ahead and take a look. Right away, I see the X here, and I know that these are vertical angles. Okay, and vertical angles are equal to each other, so my equation is going to be 2x plus 2 equals 130. And now we can solve for x. So let's separate our workspace like we always do. I'm going to take away 2 on both sides, and we end up with 2x equals 128. And then we can go ahead and divide both sides by 2. And we end up with a final answer of x equals whatever 128 divided by 2 is, which is 64. Okay, and so x equals 64 as a final answer. Okay, number 2, write and solve an equation to find the value of x. Okay, I'm looking at my relationship, and I see the x here, but there's nothing over here, so it's not vertical angles. So if I go like this, I see both of these are on a straight line, and I know that they equal 180 degrees. Okay, when we add them together because they're supplementary angles, and supplementary equal 180 degrees. And so we can write the equation 15x plus the 15 equals 180. And let's go ahead and solve for x. So we're going to go ahead and subtract 15 on both sides. And we end up with 15x equals 180 minus 15. Which is 165. And again, we could do it in our heads, but if it's a test, I don't want to make any silly mistakes. We're going to isolate the variable and divide both sides by 15, and we end up with x equals 165 divided by 15 equals 11. Okay, and if I want to double check and make sure that I'm correct, I could put 11 in for x, so 15 times 11 is 165 plus the 15 equals the 180. Okay, and so let's go ahead and make sure we put our answer, and we're all set with that. Okay, all right, now number 3, I notice right away that these two form a 90-degree angle. Okay, so these are called complementary angles. Complementary makes a corner. Okay, and so my equation would be 65 plus the x plus 2 angle equals 90 degrees. Okay, draw my line down, okay, to separate my workspace. And the first thing that I'm going to do is combine like terms. Okay, so I'm going to go ahead and combine my constants there. And so we have 67 plus x equals 90. And now we can go ahead and subtract 67 from both sides. And that's going to get us our answer already. So x equals 90 minus 67. And we get 23 equals x. And so there we go. And we highlight our answer. And we're good. All right, let's take a look at this one. We just need to find x, not the actual angle. So right away, I see that these are both sitting on a straight line. So they're supplementary angles, and supplementary sit on a straight line, and they equal 180 degrees. So that creates my equation, 132 plus 5x plus 4 equals 180. Separate our workspace. Right away, we're going to combine like terms when we have a whole bunch of terms on one side. So the 132 and the 4, and that puts us at 136 plus 5x equals 180. Okay, now we can go ahead and subtract 136 from both sides, and we end up with 5x equals 180 minus 136, puts us at 44. And let's isolate the variable divided by 5. And again, just trust your math. We know that 44 doesn't work evenly nicely when we divide by 5, but that's okay. We get 8.8, and if you're unsure, then you just test it out by putting 8.8 in for x. And so if you want to test it out, we have 8.8 times 5 equals 44 plus 4 is 48 plus the 132, and we get 180. So this is actually correct. Trust your math. Okay, but it's always good to double check if you're not sure. All right, now we're on to lesson 3, and lesson 3 is all about parallel lines with a transversal. And a transversal just means we have a line or line segment cutting through those parallel lines. So some information. We know measurement of angle 5 is 16x, and measurement of angle 3 is 10x plus 30. First thing I would do is write them in there. So angle 5 is 16x, and angle 3 is 10x plus 30. And I would just write them right in there. The other thing we do, remember, is we highlight your interior in between the parallels. And so I can see both those are interior. So my next question says circle the relationship. So they're definitely both interior, and are they on opposite sides of the transversal? They are, so they're called alternate interior. And I know that alternate interior angles are equal to each other. So this tells me the equation I can write. So we can write our 10x plus 30 equals 16x. And we can solve for x now and figure that out. And they only want the value of x, not the actual angle value. Okay, so let's go ahead and start moving things around. So I'm going to subtract 10x from both sides. And we end up with 30 equals 6x. And now we can go ahead and isolate the variable by dividing both sides by 6. And we end up with x equals 5. Okay, and so we're going to go ahead and put that in our work right there. Okay, all right, next one over here, let's take a look. Measurement of angle 6 is this. Measurement of angle 1 is this. First step, I'm going to highlight in between my parallels so I can see my interiors. I'm also going to label these angles. So angle 6 is 4x minus 10. And angle 1 is 2x plus 10. All right, are they both interior? Nope. Are they both exterior? Nope. Are they in the same location? Yes. So they're corresponding. Okay, same location means they're both below the parallel and they're both to the left of the transversal. Okay, so I know they're equal to each other. Okay, and so that helps us to write our equation then. So we have 2x plus 10 equals 4x minus 10. Okay, so let's separate our workspace. Now notice this one, we need to find the value of x, but then we have to write the actual angle for angle 6. So we are going to have to plug in our x. Okay, let's go ahead and start moving some things around. So I'm going to go ahead and subtract 2x to both sides to move that over. So we end up with 10 equals 2x minus 10. Now we can go ahead and move our 10 over by adding 10 to both sides. And we end up with 20 equals 2x, and this is feeling good. Divide both sides by 2, and we end up with x equals 10. So we solved what x equals, but now we need to find the measurement of angle 6. So let's go ahead and plug that in there. We have 4x minus 10, and we want to plug in a 10 for x. Okay, so we can go ahead and easily do this. 10 times 4 is 40. And then minus 10, the actual angle is 30, but make sure you put degrees. Okay, all right. Let's go ahead and take a look at number 7. Draw a triangle freehand with one right angle, not angles, and 2 congruent sides. Okay, so I know it's and then I have to classify the triangle. That means just name it by its angles and sides. And I have to use the notation to show congruent sides. So that means that I need to start off, I know I need right angles. Okay, but I know I need 2 congruent sides. So I'm going to go ahead from this point, I'm going to go out. Let me get the straight line, and I want this one to be about the same size. So I'm going to try to keep them as close to that same size as I can there, like that. And then we can go ahead and connect the 2 points. And then I need to use the notation. So first I'm going to show the 90-degree angle, and then I'm going to put my notation here and here to show that those are the same size. Okay? And so what is the triangle name? Well, by angle, it is a right, and by sides, because it has 2 congruent, it is isosceles. Okay, so it's a right isosceles triangle. Okay, so there we go. That's what you have to do, all those pieces for that. Okay, that's why it is 4 points. Okay, all right, number 8, solve for x and classify the triangle by its angles and sides. I can do that already. I know this is 30 miles and this is 30, so they're actually the same length. And my angle here is obtuse. So I start by angle, and it's an obtuse isosceles triangle. Okay, if they were all smaller than 90, it would be an acute triangle. Okay, and because we have 2 sides the same length, it's isosceles. If they were all different, it would be scalene. If they were all equal, we'd have equilateral. Okay, so solve x and classify. So we do need to solve x. We have 104, 38, and x. I know because of the triangle sum theory that 38 plus the 104 plus the x has to equal 180 degrees. Okay, so let's go ahead and add these up and figure out what this total is. So 104 plus 38, okay, is 142. And now I can go ahead and subtract. 180 minus 42, what does x equal? 180 minus 42 is 138. And so that can't be right. That means I must have typed something wrong, right? Because we can't have 2 obtuse angles. So 180 minus 132, minus 142 equals 38. That's a little bit better. Okay, so 180 minus 142 equals 38. So there we go. So x equals 38 degrees. Okay, and there we go. So I'm going to highlight my answer here. Okay, and I feel like I just want to double check my work. And this is what you should do on a test just to make sure you're good. 104 plus 38 equals plus 38 equals 180, so we're good. It's always good to double check if you're not sure. Okay, all right. In triangle ABC, the measures of the angles A, B, and C in order are this ratio. Find the measure of each angle. So remember, a 1 is just going to be x, and so we know the angles of x and 4x and 10x, that's the ratio, all have to add up to how many degrees? Well, we know they have to add up to 180 degrees. And so there's our equation to solve for everything. So let's go ahead and combine like terms first of all. Okay, so we're going to get all of these combined, x, 4x, and 10x. And so we have 10, 14, we have 15x equals 180. And then let's go ahead and isolate the variable, divide both sides by 15, and we end up with x equals 180 divided by 15. Our x's all equal 12. Okay, so angle A, remember, was just x. Okay, angle B was 4x, and angle C was 10x. So if I put 12 in for all these, what is the actual angle? So we have 12 degrees. We have 48 degrees. and we have 120 degrees. And if you add those up, they should all add up to 180 degrees. And so that's how that works. Okay. All right, let's go ahead and solve for x. So what is the measure of x? X is over here. X I can see is an external angle. So I actually know that this is equal to this plus whatever that is, right? But I don't know what that is yet, so let's see if we can figure it out. Well, I know that this, we could call this y, right? I know that these are supplementary angles. So this is 180 degrees. So I could do 180 minus 42, okay, equals 138 degrees. So now I know that this spot right here is 138 degrees. And I know that 138 plus 28, so 138 plus 28 equals x here, okay? Because they're all remote interior angles. So let's go ahead and figure out what that is. 138 plus 28 equals 166. So x equals 166 degrees. Okay. We also could have done that. I think maybe that is the only way to do that, actually. There's probably other ways, but that's going to be, there's no reason to go vertical angle over there and that kind of thing. Okay, so that's your process for that one. All right, let's find the actual area of bedroom 2 if the scale is 1 inch is 3 feet. So there's the scale. Let's find bedroom number 2. So bedroom number 2 is down here. Okay, and like I said, you could do a proportion, okay, of 1 inch is 3 feet. So what is 4 inches? Things like that. But I really don't see that as the quickest, most reasonable way to do it. If you know an inch is 3 feet and you have 4 inches, that's just 4 times 3. Okay, so we would just multiply by 3 and we'd get 12 feet. We would multiply by 3 and we would get 9 feet. Okay, so that's really the quickest way. This would count as the work. Okay, but you do need to find the actual area. Okay, so don't forget about that. So this would also continue as work. Okay, and you would have to have area equals 12 times 9. Area equals, and even if you know 12 times 9, I would plug it in anyway just to be sure. Okay, because it's a test. And area is in feet squared. Okay, all right, now let's go and write that down. 108 feet squared. Okay, and so I did my work and have my answer. All right, 2 triangles are similar, okay, which means they've been scaled up or scaled down. What is the scale factor from, and this is what's important, from the small to the large? So we're starting at the small. You can just pick any number you want. I'm just going to pick the 5 and the 10, but notice they're on the same side. Okay, you can't pick the 5 and the 6. Those aren't the scaled sides. You need to compare the same things. So my starting is 5, my final is 10. What is the scale factor from small to large? Well, my multiplier is times 2. So the scale factor is right there. Okay, and that's all you need to do. So I have my work of filling out the table and my answer. Okay. All right, let's go down here. Name the figure, then find the number of faces, edges, vertices. I notice it has a rectangular base. So, and I also notice it comes up to 1 point. So I know it's a pyramid. What kind is it? It's a triangular pyramid. How many faces? Well, it has 1, 2, and then the back. So 3 going around, 1 on the bottom. So 4 faces. How many edges? Remember, the edges are the line segments. So 1, 2, 3 going around. Be systematic about it. Okay. And then 1, 2, 3 on the bottom. So 6 edges total. How many vertices or corners? 1, 2, 3, 4. And there we go. So just be careful, be systematic about it, and you'll be fine. Name the figure. So I know it's a prism because it has parallel bases. Okay. What kind of prism? Well, look at the shape. It's rectangular. Okay. So we have rectangular prism. Okay. And then we can identify what shapes we get from the cross sections. And you can see here, we're giving you the images to make it nicer. So what shape do you get? We're looking at this. We get a rectangle. What do you get vertical? We get a rectangle. And what do you get diagonal? We still get a rectangle. Okay, and I'm going to tell you right now, we just did these for the practice test, so it's going to be a different one for the test. Okay, so just make sure you look up and make sure you look back at your notes to prepare. All right, that's it for the test. If you have any questions, let me know.